Okay, our learners, today I want to show you how to perform block bootstrap using R. Okay, so if you wonder what block bootstrap are, they are methods for really suitable for cluster data such as panel data and time series. Okay. So basically, you have correlations among certain grouped data points. And when you do Bootstrap, you don't want to destroy that correlate structure among those data points. You want kind of treat them as a block, to resample them together. So that's why I call it a block Bootstrap. Okay. And block Bootstrap really maintains or keeps the correlation structures between the variables in the blocks. That's the key, right? Okay, in this talk, I will show you two examples. Example one is panel data. Okay, so let's start. So set a random seed. Let's create a panel data set, 10 subjects, 5 years, and we create an ID variable, create a year variable from 2001 to 2005, and then we can generate covariates and outcome. So the temperature, I think the temp, is from a normal distribution, and then we get a treatment, field treat, which is a kind of using a formula of 0.5 times temp plus random sample point from a normal distribution. And then we put them all together, the ID, the year, and the temp, and the yield treatment. Okay. And here's what the data looks like. Okay. So basically, you got the IDs, and then you got the years. For different IDs, you got different years. So year, the variable year is the clustering variable. Okay. All right. So in order to perform the block Bootstrap, we need a library tidyverse. Okay, do some data manipulation. So let's say we're gonna do 100 Bootstrap sample. And now this is really important. We use the function split to split the data according to the clustering variable year. Okay, split of data and data at a year. Okay, and if I look at what the blocks looks like, you can see it's actually a list. Okay, and with for different years. Okay. And the next one, we write a function for generating a single Bootstrap sample. So you get a block Bootstrap sample function of reading blocks, and then you do the sample the blocks using the sample function to resample the blocks, the size equal to length of blocks, replace equal to true. So you're not resampling the individual data point, you're sampling the blocks. Okay. And when you do that, you bind the rows, and then that's it. That's created the blocked Bootstrap sample for a single Bootstrap sample. And now we generate Bootstrap samples and fit models. The first is, so we do the coefficients. So we do replicate number of bootstraps as sample equal assigned as the block Bootstrap sample of blocks. And then the coefficient is we do a linear regression. So we want to bootstrap that the yield tree regressed on temp. Okay, the data equal to that bootstrap sample. We want bootstrap the coefficient from that linear regression model. Okay. Okay, and now we put everything into a data frame using the bind underscore rows. So you use L apply. So this coefficients is actually a list. So you apply this function of x as a data frame of x, and ID equal to bootstrap ID. Okay, so now you get a coefficient data frame, and you want to do the mean of the bootstrap sample temperature coefficient, and then the standard deviation of the bootstrap temperature coefficient, and so you print them out bootstrap mean for temp, which is the mean underscore temp, which is 0.448424. And then the bootstrap SD, the standard deviation for temp, is the SD underscore temp, so 0.06584911. Okay. Of course, you can also extract 95% percentile confidence interval. So basically, you just extract the percentiles at 0.025 and 0.975. And this is a 95% confidence interval for temp. This 0.346426 and 0.586218. Okay. And of course, you can print out print out this bootstrap sample. It looks like distribution, but this is that vertical line, the dotted line, that's the point estimate, and you got the bootstrap samples distributed as like that. Okay. All right. So example 2 is the time series. We can use the boot library, and we use the built-in data set called air passengers. Okay, so if you print it out, it looks like I have several, more than 100 data points as a sequence, as a string of numerical values with the data as a time series data. And then you write a function to calculate the mean, and then you set a seed, and you do the tsboot. You use directly the function tsboot to do the bootstrapping. Statistic equal to stat underscore function. We just want to do the means. The R, the replicate bootstrap sample is 1,000, so L is 12, sim equal to fixed. Okay, if we do that, and then we do the original statistic, which is 280.2986, and you got the bootstrap one is centered around that data point estimate. Okay. No, centered around T0, which is the original statistic. Okay. Another way you can generate the bootstrap or the block bootstrap of the time series is you can use a library called the T series. Okay. So we can load that in here. And then set seed. Now we use the TS bootstrap function in that library, writing the TS data, and then number of bootstrap 1,000 be equal to 12, and then byte type equal to block. And then you get the mean of the bootstrap, and you got the standard deviation of the bootstrap. Simply use the mean as SD function in base R. And then you can get the confidence interval using quantiles at 0.025 and 0.975. And you can print out the mean, standard deviation, and the confidence interval. And of course, you can also load in the library ggplot2 if you want to do some visualization. So put the statistic equal to boot out at t into a data frame, and then you got the mean, and then you can print them out, make a histogram of the bootstrap distribution of the statistic. Okay. So that's it. This is how you do block bootstrap for panel data and time series data. Thanks for watching.